Hello, my name is Aisyata Amira binti Azlan. I'm from the EY section 1/1. Today, I'm going to share about the comparison of process heat collectors with respect to technical and economic conditions. So, first of all, process temperatures found in industrial processes are manifold, ranging from low to medium and to high. Low and medium temperature process present a high share of heat demands on the mining, food and beverage, tobacco, pulp and paper, machinery and transport equipment manufacturing sectors. High temperature presenting a high share of heat demand on the chemical, non-metallic, minerals and basic metal production sector. As thermal losses in a solar collector are directly related to the operating temperature and different solar collector technological concepts. Aiming the minimization of heat losses at increasingly higher operating temperature, the range of solar collector technologies suiting process heat application is also wide. Stationary, tracking, airfield, evacuated, all of them presenting optical and thermal specificities and falling into different technology cost range, determining their technical and economic performance under prescribed operating conditions. Considering the interrelation of technological, methodological, and economic aspects involved in the preliminary technical economic analysis stage, the report provides an overview of the most relevant topics that it included. First, solar collector technologies, providing an insight to the different available technologies, operating, temperature range, and operation requirement. Second, solar yield calculation methods and tools, providing simplified yield estimate approach and the production of key figures, enabling a due technical assessment. Third, economic analysis, highlighting the most relevant aspect to be considered in the investment analysis and providing methodologies enabling the production of key figures enabling a due economic assessment. And the last one is decision factor, gathering technical and economic assessment result into the establishment of the boundary condition for investment viability.
My name is Akwan Saifuddin bin Waka. I will explain about the solar collector technologies that I attend the talk last week. There are two types of solar collectors. The first is stationary, which is flat plate collector, and vacuum tube collector with CPC. The second is tracking types. Tracking types are parabolic through collector, linear Fresnel collector, and the last one is concentrating disk collector. About the temperature levels, solar heat collectors are only effective if they can produce a useful temperature to meet the needs of any attached heating job at any given moment during the daylights. So it's always preferable to design solar or hydronic heating system so that they can operate effectively at lower temperature whenever possible. Efficiency of solar collector is a relationship between the total energy available and the useful part of it that is put to good use. The thermal efficiency of a solar heat collector is not static. Clearly, there is a need for a standard way of testing and comparing solar heat collectors. And in United States, that standard is maintained by the Solar Rating and Certification Corporation, which is they call SRCC. The SRCC provides our most widely used national solar heating test standard. They administer a certification, rating and labeling program for solar collectors and a similar program for complete solar water heating system. The labels themselves can be useful when making an energy performance comparison, since they show a standard energy performance rating similar in concept to those found on refrigerators and automobiles. When this situation is boiled down mathematically, it turns out that there are only three things you need to know to evaluate the collector efficiency for any heating application, such as how hot is the fluid you want to heat, how cold is it outdoor, and lastly, how sunny is it. The RCC provides collector test results, which include the slope and intercept data for each collector test. The slope and the intercept allows you to draw a straight line on a graph that defines the collector efficiency for any conditions.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amin bin Rashid. I'm from BEEY Section 1. My metric number is B01910244. Okay, I will talk about the collector performance rating. Energy performance represent the most important technological criteria for the comparison of the different collector product technology. Collector performance rating can provide useful information for preliminary feasibility study at the pre-design stage for solar process heat installation. This chapter focuses on the concept of thermal energy output. The efficiency of indigenous power curve represented in chapter 3 must be regarded as the graphical representation. Okay, other issue, heat transfer medium. Collector performance parameter used for energy output calculation are determined according to the ISO under the defined test condition. Collector field ISOs losses. Collector field losses can include different considerations such as heat loss due to the piping depending on the pipeline, on the connection, on the quality of the thermal insulated use for self-shading effect. System loss and configuration. Besides collector field losses, significant losses can also occur at storage, heat exchangers, distribution pipes, as well as the system component, which are neglected in the collector yield calculation. Load profile. As a consequence of neglected system design and operation, collector energy output calculation assume in most cases and also the methodology of present. Okay. Methodology. Instantaneous power can be integrated over different period of time to get information of the thermal energy output of the collector under specific condition. So it must be space heating under the 100 degrees Celsius. Annual collector energy output. Annual approach calculates the annual thermal energy cost 1 year. It represents the comprehensive method. So it will account more accurately reproduce energy gain and loss of the collector. Okay, this is a graph. The graph means the performance comparison of two collector based on instantaneous power from the left and the annual energy at the right output. Okay. The instantaneous power curve refer of the irradiance of the 1000 watt meter per square and the ambient temperature of 20 degrees Celsius. The annual output is calculated for 45-degree tilt angle, source orientation, and the weather data of Seville. Okay, this is the methodology has been used in 2011 within SOLAR, K-Mark, and the Canadian European Mark scheme. The calculation are carried out with the software Sinner calculation. The annual approach of the implemented information. As already pointed out, collector energy output is useful assessment criterion for the preliminary feasibility analysis, but cannot and shall not be replaced detailed system simulation. Extemporary complex calculation based on different methodology for solar process heat gas study investigated the framework of Task 49, emphasizing the impact of relevant aspect of the system design and load profile. Daily collector energy output, daily methodology, and 5 different temperature differential with difference between collector ambient temperature. Okay, this is the calculation. This is the calculation. Okay. The figure below clarifies the basic aspect for the comparing performance of two different collectors by the means and spacing power. Okay. Okay, so in conclusion, so it will be the daily collector output will describe the output comparison, the annual approach, and then the output comparison of the radiation, medium radiation, and low radiation affects the efficiency of the solar panel. Okay, that's all from me. Thank you. I will pass it.
Hello, Assalamualaikum. My name is Akmal Rushaidi bin Muhammad Razi, student from 2BEY, Section 1, Group 1. My matrix number is B081910254. Alright, now I will explain to you about my part, which is the calculation of input and parameters. Alright, for simplified calculation, there is 3 different kind of information needed. The first information is the collected data. The second information is the location and climatic data. The third information is the operating condition. Alright, for the first information, which is the collected data, it consists of efficiency parameters including IAM and the collected area. It is recommended to use data from certified measurements according to the test standard ISO 9806. Another important aspect to be taken into consideration is the reference collector area used for determining the efficiency parameters. Alright, for the second information, which is the climatic data, the choice of suitable climatic data is crucial for the planning of solar energy systems, even at a pre-design stage, and in case of simplified collector output calculations. There is 3 relevant aspects to take into account and requirements to fulfill for the task. The first aspect is time resolution. The second aspect is time coverage, and the third aspect is spatial resolution. Alright, for the operating conditions, it is the last aspect to be considered in the output is the conditions at which the collector is expected to operate. The calculation has to be carried out for a mean temperature, which refers to the temperature of the process. For the collector orientation, azimuth and tilt angle as well as tracking mode and axis have to be defined. Alright, that's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Al-Hadrami bin Rodin Jaya. My metric number is B081910056. I will be discussing about the conclusion. Solar power is an immense source of directly usable energy and ultimately create other energy resources such as biomass, wind, hydropower, and wave energy. Most of the Earth's surface receives sufficient solar energy to permit low-grade heating of water and buildings, although there are large variations with latitude and season. At low latitude, simple mirror devices can concentrate solar energy sufficiently for cooking and even for driving steam turbine. The energy of light shifts electrons in some semiconducting materials. This photovoltaic effect is capable of large-scale electricity generation. However, the present low efficiency of solar PV cells demand very large area to supply electricity demands. Direct use of solar energy is the only renewable means capable of ultimately supplanting current global energy supply from non-renewable sources, but at the expense of a land area of at least 500,000 kilometers square. Solar thermal power generation has some properties that make it very special, perhaps even unique among all the forms of renewable energy. keep in mind that solar thermal is very different from solar photovoltaic. Solar photovoltaic are what people are generally referring to when they say solar panels. Solar thermal plants look and function very differently from photovoltaic.